So when it comes to thinking about like all these ideas of, they sound lovely, don't they? Let's have an inquiry, exploratory classroom and that kind of thing. And then you're like, how do I do this with the quotient rule? I don't know, right? Get into groups and brainstorm 99 wrong ways to differentiate a quotient, right? The first thing to say is, yes, you are right that our KLA is different. Every KLA is different, right? And we do have a unique struggle in this space. Probably the most helpful thing that I would say here, just out of my own experience, is I would distinguish between what I like to call big I inquiry and little I inquiry, right? So big I inquiry is like, okay, we're gonna do a 3-week project on this, guys. You are gonna have to do some investigation. You're gonna have to do some digging. I'm not gonna tell you the answers. Sometimes there just may not be an answer. A lot of the mathematical problems that we have in the real world just don't have one single answer, right? And you're gonna have to work through that. You're going to have to iterate and prototype and hit brick walls, and that's going to be part of the learning process, right? That's big I inquiry. Mathematics is not as well suited to that kind of inquiry as, say, the humanities, or even, say, some of the design or the Kappa subjects. And that's fine. That's okay. Our subject is quite granular in talking about individual independent skills that we want students to learn. But that doesn't mean inquiry is just like throw it out the window, right? Little I inquiry happens in my classes all the time. It might just take like 10 minutes at the start of a lesson. For example, I might say to students, okay, so I've been teaching 3D vectors in Extension 2 recently, right? And you know, I don't know, hold on a second, I'm thinking about the age of the syllabus. Did you guys do 3D vectors? Some people did, so there's like, yeah, okay, so anyway. The important part that I want to get across to you is, just like in coordinate geometry, you're like, y equals 3x minus 5. I can visualize that's a straight line where it goes, right? X squared plus y minus 3 squared equals 25. That's a circle. I can visualize where that goes. Y equals 1 on x and on and on and on, right? In 3 dimensions, this is a little more tricky, right? If you try and extend things from 2D into 3D, sometimes it just works fine, and other times it blows up, right? Now, what am I going to do with students to help us encounter that? I could just say, hey, if you want the equation of a straight line in 3 dimensions, you can't just take the equation from 2D and then just put some z's in there for a third axis, right? I could just tell you straight out, that's not how we do it. This is what's the vector equation of a line. There's a lambda in there, off you go, right? I could do that. Or I could say, hey, pull open GeoGebra for me. I want you to see if you can come up with the equation of a line. Like I'm trying to take out of their hands all of the legwork that I had to do by hand to try and draw things. Use the technology for a purpose like this. Throw in any equation you like. Put in x's, y's, and z's, and what do you get? What you'll find is, if you put in, say for example, we know what the general equation of a straight line is, ax plus by plus c equals 0. You try and put a z in there, ax plus by plus cz plus d equals 0, and you'll never get a line, you get a plane. What's up with that, right? That's just 5 minutes at the start of my lesson, but that's inquiry to help them feel why it is that I'm going to now introduce a lambda and this weird other form for an equation of a line, right? Now that form of inquiry is happening constantly in my classroom. I'm thinking really carefully about the kind of questions that I pose to students, and this is not the question you ask, but I think it's the answer you need. It's way underrated how important questioning is in our classes, right? Do you know about the different kinds of questions you can ask students to help get their understanding? You can ask assessing questions, analyzing questions, advancing questions, the kind of questions that you say, but why do you think that that is? And then you walk away and you don't wait for the answer because you want them to think about it, right? So these kinds of things are all the different mechanisms for introducing little I inquiry into your class. And if you go and look, say for example, look up the Resolve maths project that was funded by the Australian Academy of Science, right? Its tagline is maths by inquiry. And there's so much phenomenal maths that you actually can learn in those ways, in small ways in your lessons. So don't be intimidated. It might not be the main way that you do things. You'll probably do explicit direct instruction 75 to 80% of the time. That's fine. But if you never do inquiry, then there's a problem. You want to bring it in at the appropriate times.